Hi everyone, welcome back to your physics class. I'm back again with another video lesson. I hope you're all doing well. Guys, today's lesson we're going to talk about refraction in chapter 6. In this chapter, we have three sections as you can see here. Section 1 about the refraction, Section 2 about the thin lenses, and the Section 3 about the optical phenomena. Let's get started from Section 1 about the refraction. So what is refraction? After we studied reflection, is the change of the direction of electromagnetic wave when encountered the smooth surface such as a flat mirror. The light will be reflect, and according the law of reflection, the angle of incidence is equal to the angle of reflection. Okay, so for the reflection, the light, like the mirror, when the light strikes the mirror, the light cannot pass through the mirror because mirror is not transparent medium. Instead, the light will be reflected. Okay, but refraction is different from reflection. In refraction, the light passes through two different mediums. When the light travels from one medium to high density or low density into the medium with low density or high density or different densities, the light will be bent. Okay. In this case, for the refraction to be occur, the medium should be transparent medium, like diamond, water, glass, air. Okay, because in refraction, the light must be passed through the medium. The definition of refraction, guys, look, refraction, the bending of wave front, the bending of what? The bending of a wave front, like such as a light. As the wave front passes between two substances, between how many substances? Two substances. One of the condition for the refraction to be occur, we need two substances. Okay, so the light must be traveled between two substances, in which the speed of the wave differs. What do you mean by the speed of the wave differs? It is that the two substances must have different density. Okay? So when does the light bend or refract? When the light travels from one medium to another medium, but these two medium must be different in density, like from water to air or from air to water. As you know, the density of water is not equal to the density of the air. The water is denser than the air. So this is refraction of the light. So the refraction is what? Is the bending of light. As you can see in these two figures, the first figure, we have two substances, air and glass. When the light travels from air, low density compared with the glass. Low density, low index of refraction, but high speed. Whenever the density decreases or less, for the less denser medium, the speed of the wave is faster. Okay, when the light travels from air into the water, what happens to the light? Part of the light reflect and the other parts refract, or it bends. Okay, the light bends toward the normal when the light wave travel from low density to high density. Glass here is high density, high index of refraction, but low speed. Okay, so we have two different types of bending toward and bending away from the normal. But before explain the types of the bending, I would like to show you this simulation. In a PhET simulation, look at this experiment. Guys, look. In this case, how many mediums do you have? Two. The first medium is air, and the second medium is water. Air and water. These two substances have different density. Which one is denser? Absolutely, the water is denser. Okay, water has more density, has more index of refraction, but less speed. Okay, while air has low density, low index of refraction, but high speed of wave. Okay, so the speed of wave is faster in air, after that water, after that glass. But density is bigger than in glass. The density of the glass is more than the density of water and more than the density of the air. Guys, look, this is the source of the light. When the light hits the surface, okay, look, this is the light wave. Part of the light reflect. We don't need this reflection. The other part refract. As you can see here, when the light travels from air into the water, the light does not move in a straight line. Instead, they bend. Okay, this bending sometimes toward, you know that this is normal. We have two different types of bending toward the normal or bending away from the normal. Okay, why the light is bent here? Why we have refraction here? Because the light travels between two medium different densities. Okay, guys, if you make the second medium air, look, now both substances are air. How many substances do we have? One, air. When the light passes in one substance, the refraction will occur? No, never. The refraction will never happen because we have only one substance. But in the case if you have two substances with different densities, such as air and water, look, as you can see here, the light bends toward the normal. When does light bend toward the normal? Whenever the light travels from low density to high density. From low index of refraction to high index of refraction. From low speed to high speed of wave. Okay? Once again, listen carefully, please. When does light bend toward the normal? When the light travels from low density to high density, from air to water, from low index to high index, from high speed to low speed. The light will bend toward the normal. So in the next case, when does the light bend away from the normal? When the light travels from high density to low density. From what? High density to low density. Okay, let's make the first medium as water. For example, the first medium is what? Is water. And the second medium is air. How many substances do we have? Two. These two substances are different in density? Yes. So does the light, when the light travels from water to air, the bending of the light it bends toward the normal or away the normal? It should be bent away the normal. Look, let's try it. Sorry, let's make the index of refraction. It's high index of refraction. Okay, guys, look. When the light travels from high density to low density, it bends away from the normal. When does light bend away from the normal? When it travels from high density to low density, high index to low index of refraction, low speed to high speed. Okay, all of them correct. Be careful. Let's go back to our book. Guys, look. Refraction is the bending of light whenever the light travels between two medium and two substances with different densities or with different index of refractions. Okay, if the light, guys, look, if light travels from one transparent medium to another at any angle other than straight on the normal to the surface, look, guys, I forgot to tell you when does the refraction does not occur, even in the presence of two different substances. Look at here. Assume that this is air and the second one is water. So at what angle or at which angle the light does not refract? When the incoming light is perpendicular to the surface. When the incoming light is perpendicular to the surface, or when the incoming light is traveled along the normal. Do we have refraction? No. Even we have two substances, different densities, but we don't have refraction. Why? Because when the light travels along the normal, the light does not bend. Okay, so we don't have refraction in this case. Okay, look. If the light travels from one transparent medium to another at an angle that's straight on a normal to the surface, the light ray changes direction when it misses the boundary. As in the case of reflection, the angle of the incoming and refracted rays are measured with respect to the normal. For the study of refraction, the normal line is extended into the refracting medium as shown in the figure. The angle between the refracted ray and the normal is called the angle of refraction. Look, assume that we have two mediums. This is air and this one is water. When the light travels from air into the water, this is normal. Guys, what is this? This is normal. So what happened to the light? It bends. It bends toward the normal. Why? From low density to high density, it bends toward the normal. Okay? So this angle is called the angle of refraction, and this angle is angle of incoming, of incidence. What is the angle between the refracted ray and the normal? This is normal. Is the angle of refraction theta sub r. What do you mean by theta sub r? Theta sub r is the angle of refraction. But when the light travels from like water to air, so in this case, when the light travels from high density to low density, this is normal. It bends toward or away. It bends away from the normal. Away from the normal. This is theta r. Okay? It bends away from the normal. Okay. Sorry. This is the angle of refraction, and this is the angle of incidence. Is it clear? The angle of refracted ray and the normal is angle of refraction. Refraction changes light's velocity. Glass, water, ice, diamonds, and particles are all examples of what? Transparent medium. Okay? Okay, guys, the example of transparent medium, glass, water, ice, diamond, and particles, okay, through which the light can pass. The speed of light in each of these material is different. The speed of light in each of these material different. So which one is faster in which medium? In the medium with the low density, such as air. The speed of the air is fast. The speed of light in air is faster than the water, faster than the diamond, glass, ice, okay? The speed of light in water, for instance, is less than the speed of light in air, okay? Guys, look. Speed of light in air bigger than speed of light in water, and speed of light of water is bigger than speed of light in glass, okay? So this is very important. But density of air less than density of water and less than density of glass. Which medium is denser? Glass. Okay? And the index of refraction of air less than index of refraction of water, less than index of refraction of glass. Density and index of refraction is the same thing, okay? But speed of light is different. Figure 62, when light moves from one medium to another, part of it is reflect and part is refract. Figure A, when light ray moves from air, low density, into glass, high density, refracted portion is bent toward the normal, whereas the path of a light ray moving from glass into the air bends away from the normal. Okay? Explanation of refraction in terms of the wave model. This is the same thing that I explained. Okay? The two law of refraction is very important, guys. Be careful. The two law of refraction. The two law of refraction, the first law states that the index of refraction for substance is the ratio. Index of refraction for the substance, it means that n. What is n? Index of refraction. Index of refraction is the ratio. Ratio, it means that the fraction. Ratio of what? Speed of light in vacuum, which is c, to the speed of light in substance, v. Index of refraction is equal to what? C over V. What is N? Index of refraction. What is C? Speed of light wave in vacuum, which is constant. 3 times 10 to the power 8 meter per second. This is C. V, also speed of light. But what is the difference between C and V? Speed of light, but in what? In a substance, such as air, water, glass. Okay? So index of refraction is unitless, guys. Index of refraction is what? Is unitless, has no unit. Why has no unit? Because both speed of light in vacuum measured in meter per second and speed of light in substance also measured in meter per second. They cancel each other. That's why index of refraction is unitless. And n always bigger than 1. Why? Because C always bigger than V. The speed of light in vacuum always faster than the speed of light in a given medium. This is the first law of refraction. Once again, listen carefully, guys. Index of refraction of substance, N, is the ratio of what? Speed of light in vacuum to the speed of light in a given medium or in a substance. This is first law. The second law, which is stated here, this is second law, guys. In second law, when light begins in air, when light begins in what? In air. This is air, okay? Light begins in air. This is normal. When light begins in air, high density, but low speed. Sorry. Low density, high speed. This is air. Low density, but high speed. And low index of refraction. When the light begins from air or begins in the air has high speed and low index of refraction. Travels into water. Travels into what? Into water. Water has high density, high index of refraction, but low speed. So it means that the light travels from high speed to low speed, low density to high density, low index to high index. Water, low speed, high index of refraction. The light rays bend toward the normal. The light rays bend toward the normal. It bent toward the normal. This is second law of refraction. This is what? The second law of refraction. And conversely, when light passes from the water to the air, the light rays bend away from the normal. Note that the value for the index of refraction air is nearly about 1. Okay, use value n is equal to 1 for the air. Index of refraction for air is equal to 1. And for water, guys, look. N for water is equal to 1. N for air. But N for water is equal to 1.333, and it is unitless. So this table is the table of the index of refraction for some substances, okay? Like zirconia, diamond, fluorite, okay? It should be given for the solving question. Only the index of refraction for air, it's not given in the question, you have to memorize. N for air is equal to what? Is equal to 1. The other must be given, okay? So this is the same thing that we studied: from air to water, bends toward, but from water to air, bends away to the normal, okay? So the actual position of the fish is here, but the cat sees the fish here, okay? Actually the fish is not here because of the refraction. For the same thing, the fish sees cat here, but actually it's not here, it's away to the normal, okay? Snell's law determines the angle of refraction. Snell's law, this is very important, guys, be careful. This is Snell's law to determine the angle of refraction. Snell's law stated that Ni sine theta I is equal to Nr sine theta r. What is Ni? The first medium. Index of refraction for first medium. Index of refraction for the first medium N R index of refraction for second medium, theta I angle of incidence or incoming, theta R angle of refraction. Okay, this is Snell's law to determine the index of refraction and the angle of refraction. How can you rearrange the equation in order to determine theta R, theta I, NR or NI? NI sine theta I, NR sine theta R. So we can make 4 different equations based on this equation. For the first one, to determine theta R is equal to sine inverse Ni sine theta I over Nr. This equation can be used to determine what? Angle of refraction. The second equation, theta I is equal to sine inverse Nr sine theta R over Ni. Third equation, to determine Nr. Nr is equal to what? Is equal to Ni sine theta I over sine theta R. Ni, index of refraction of the first medium, is equal to Nr sine theta R over sine theta I. Okay, so we can make 4 different equations from the Snell's law. The first equation to determine angle of refraction, the second one angle of incidence, the third one to determine index of refraction for the second medium, and I to determine index of refraction in the first medium. Look at sample problem 6a. According by using Snell's law, a light ray of wavelength 589 nanometers. So we don't need this wavelength. Just this wavelength is given to confuse the students. Produced by a sodium lamp traveling through the air. Traveling through what? Through the air. So it means that the first medium is air, which is equal to 1. First medium is Ni for air is equal to what? 1. This is constant. Strikes a smooth flat slab of crown glass. Okay, the second medium is crown glass, which is equal to 1.52. You have to look the table to determine the index of refraction for the crown glass. At which angle the light strikes from air into the glass? Theta I at 30 degrees. Okay? Find to the normal. Find the angle of refraction. What is the known angle of refraction? Which equation can be used? The first equation. Theta R sine inverse Ni sine theta I over Nr. It's very easy. Sine inverse Ni was given 1. Sine 30 over Nr 1.52. Theta R is equal to what? Guys, look. Use your calculator to determine theta R. Sorry, I forgot my calculator. It's okay, no worries. Sine 30, 0.5. 1 times 0.5 over 1.52, which is equal to 19.2. 19.2 degree. This is the angle of refraction. So in this question, because the light travels from air into the glass, it bends toward the normal. Okay? So the angle of refraction, theta R, must be less than. When theta R less than theta I, when the light travels from air to glass. But when the light travels from glass to the air, theta R must be bigger than theta I. This is sample problem 6a. Okay? Okay, guys. Practice 6a. In practice 6a, Snell's law, question 1. Find the angle of refraction. What is unknown? Theta R. Angle of refraction. Theta R is unknown. For a ray of light that enters a bucket of water, the light enters what? A bucket of water. One of the substances is water. From where? From air. So it means that in this question, the light traveled from air into what? Water, a bucket of water, okay? From low density to high density. Whenever the light travels from low density to high density, theta r must be less than theta I, or theta I is bigger than theta I, okay? When does theta I bigger than theta r? When the light travels from low density to high density. Ni, first substance, is equal to 1 for air, and R is equal to 1.333 for water. Okay? Theta R is unknown. Theta I is equal to what? At which angle? 25. This is theta I. How can I determine theta R? Theta R is equal to sine inverse Ni sine theta I over Nr. It is very easy. Just plug in sine inverse, replace Ni1 sine 25 over 1333. Theta R is equal to what? Use your calculator to determine the value. Sine 25 is equal to something, divide by 1, and sine inverse for the answer. Okay, sine inverse for the answer is equal to 18.48 or 18.5. 18.5, which is less than 18.5, less than 25. Okay, this is question 1. Question 2, for an incoming ray of light vacuum wavelength, we don't need, fill in the unknown values in the following tables. We have this table, guys, look. Based on this table, we have to determine the unknowns. For the this is first medium, Ni. This is second medium, Nr. This is theta I, angle of incidence, and this is theta R, angle of refraction. For the first row, what is unknown? Theta R. For the first row, theta R is unknown. Ni is equal to what? Branch A. Question 2, branch A. Write down the given value. For the flint glass, Ni is equal to what? For the flint glass, look at the table. Guys, look. The index of refraction Ni for the flint glass or glass flint is 1.66. But for the crown glass, 1.52. Okay? For the flint glass, 1.66, and the second medium, crown glass, Nr for the crown glass is equal to what? 1.52. Theta I, do we have theta I? Yes, 25. What is unknown? Theta R. It's very easy. Theta R sine inverse Ni sine theta I over Nr. Theta R sine inverse Ni 1.66 times sine 25 over 1.52. Theta R is equal to, because in this case the light travels from high density to low density, the light bends, look, from high density to low density, theta R should be bigger than theta I. Opposite of the previous question. Let's check. 1.66 times sine 25 is equal to something, divided by 1.52, and the shift sign is going to be sine inverse of answer. I got 27.5. Is theta R bigger than theta I? Yes. 27.5 bigger than 25. Why theta R bigger than theta I? Because the light travels from high density to low density. This is branch A. Branch B, what is unknown? Index of refraction of the second medium. The first medium Ni for air is equal to 1. Nr unknown. Theta I must be given 14 0.5. Theta r also must be given 9.8. How can I determine NR? NR is equal to NI sine theta I over sine theta r. NI is equal to 1 sine 14.5 divided by sine 9.81. Index of refraction for the second medium is equal to, now we're going to calculate. I got 1.47. 1.47, and it is unit length because it's the ratio between two speeds. Okay? Branch C, what is unknown? Theta r is unknown. Theta r is equal to sine inverse Ni sine theta I over Nr. Sine inverse Ni from air 1 sine 31.6 divided by Nr for the diamond. For diamond, Nr is equal to what for diamond? Guys, look at diamond, 2.419. Theta r is equal to what? Sine 31.6 divided by, sorry, 2.419. I got, so sine inverse 13. Okay? This is the angle of refraction. This is branch C. Question 3. Look at the question 3. A ray of light at a vacuum wavelength, we don't need this wavelength, enters a slab of transparent material. The incoming ray makes angle, this is theta I, with normal, and the refracted ray makes angle, this is theta r. Find the index of refraction of the transparent medium. Find what? The index of refraction of the transparent medium. The incoming ray, so with the normal, so you have to know the light travels from where? From the air or from what substance? Okay, from air, traveling in air. Ni is equal to 1. What is unknown? Nr is unknown. Nr is equal to what? Ni sine theta I over sine theta r. Ni is 1 sine 40 divided by sine 26. Nr is equal to what? This is question 3. Very easy. Sine 40 divided by sine divided by sine 26 is equal to 0.99. Okay, sine 40 divided by sine 20 is equal to 0.99. Okay. Section review, the questions of the section review in this section, section 1 in chapter 6. We finished this section. Now we're going to solve the question of the section review. Sunlight passes into the raindrop at an angle. When the light passes into a raindrop, it means that the light travels from air to water. Index of refraction for air Ni, this is 1.333. For air is equal to 1. Angle of incidence is equal to this. So to solving this question, theta r is unknown, is equal to sine inverse Ni sine theta I over Nr. It's very easy. Sine inverse Ni travels from air 1 by this angle 22.5 over Nr is water 133. Theta r is equal to what? This is question 1 in section review. Sine 22.5 divided by 1.33. I got 0.28, sine inverse, sine inverse. For the answer, 16.7. This is the angle of refraction for the question 1. Question 2, for each of the following cases, will light rays bend toward or away? Toward or away from the normal? When Ni is bigger than Nr. Look, A. When Ni bigger than Nr. First medium, second medium. It means that high density to low density. High density travel to what? To low density. How light bends? Bends away to the normal. It bends away. Okay? Because Ni is bigger than Nr, it bends away from the normal. Branch B, when Ni less than Nr, it bends toward. Okay? Branch C, from air to glass, low density to high density, bend toward. D, from glass to water, bend away. From glass to air, bend away from the normal. Find the angle of refraction of light enters a diamond from air. Question 3 also is very easy. Ni is equal to 1, Nr is equal to 1.419, theta I 15, theta R is unknown. Theta R is equal to, you have to do the same thing as we did in the previous question. Question 4, in which of the following situation will light from laser be refracted? Traveling from air into diamond at an angle. Yes, it will be refracted. So we have to find which one the light will be refracted in which of the following cases. The first point, the first one, does the light refract in the A? Yes. Why? Because travel from two different substances with this angle. Traveling from water into ice along the normal. Guys, look, pay close attention for this normal. Along the normal, not refraction, no refraction. We don't have refraction, even if we have two substances with different in the densities. Because the light travels along the normal, does not refract. Upon striking a metal surface, also does not refract. Traveling from air into glass with this angle, yes. A and D, yes. B and C, no, does not refract. Okay? Okay, guys. Section 3 in chapter 6 about the optical phenomena. In this section, we are talking about two topics: total internal reflection and critical angle. What is the total internal reflection? The complete reflection that takes place within a substance when the angle of incidence of the line striking the surface boundary is greater than the critical angle. So to understand the total internal reflection, you have to understand the critical angle at first. What is critical angle? Critical angle, theta sub c. Critical angle, the angle of incidence in the medium of larger index of refraction at which the refracted angle is 90 degrees in the other medium of the smaller index. Look, critical angle, when does the critical angle occurs? Guys, look, we have some conditions. This is water and this is air, okay? We have two different substances, water and air. Guys, look, for example, when the light travels from water into the air along the normal, does the light refract in this case? No. Why the light does not refract? Because the incoming light is directed along the normal. So what happened to the light? The light travels with the same direction. Okay, there will be no bending and no refraction of the light. Okay, why? Because the angle between the incoming light and the normal is 90 degrees. This is first ray. For the second ray, guys, look. For the second ray, when the incoming light makes its angle with respect to the normal, this is theta I. Okay, what happened to the light? It bends. It bends. Why? Because when the light travels with a given angle with respect to the normal, travels from one medium to another medium with different density, the light will be bent. But which type of bent? It bends toward the normal or bends away? We have to look the two substances. The light travels from high density to low density. When the light travels from high density to low density, it bends away from the normal. This is theta r. Is that clear? This is the second ray. For the third ray, when we increase the angle of incoming, for example, in this case, assume that the angle is 30 degrees. If we increase this angle, okay, with respect to the normal, from 30 to 45, for example, okay, if we increase the angle of the incidence, the refracted ray will be along the normal, the surface, along the surface, or along the boundary. So this is refracted ray. What is this? This is refracted ray. It makes angle 90 degrees with normal. So this angle is gonna be what? Critical angle. So what is the critical angle? Is the angle of incoming light, when the angle of refracted ray is 90 degrees with respect to the normal. This angle is called what? The critical angle. Look, critical angle, the angle of incidence in the medium of larger index, from larger index to smaller index of refraction, at which the refracted angle, theta r is equal to what? 90. At which the refracted angle is 90 degrees to the medium of the smaller index. For the critical angle to be occur, the light must be traveled from high density or from high index to low density. So for the first medium we have Ni, for the second medium we have Nr. But when does the critical angle occur? When the light travels from high density to low density, high index to low index, low speed to high speed. So in the critical angle, can we say Ni always bigger than Nr? Yes. Ni always must be bigger than Nr. So what is the total internal reflection? In total internal reflection, if the angle of incoming is bigger than critical angle, for example, 48. If the angle of the incidence is bigger than the angle of a critical angle, the light does not refract. Instead, it's gonna be reflect. When does the light does not refract? It's gonna be reflect if the angle of if the angle of incoming is bigger than the angle of critical angle. So in that case, the light does not refract. Instead, it's gonna be total internal reflection. So what is the total internal reflection? The complete reflection that takes place within substance when the angle of incidence of the light striking the surface greater than critical angle. When does the total internal reflection occur? If theta I is bigger than the critical angle. Okay? Bigger than the critical angle. And also the Snell's law can be used to determine the angle of the critical. The first ray does not refract. We have refraction bent away. For this case, we have angle of critical angle. This is the total internal reflection. And also the Snell's law can be used to determine the critical angle. Critical angle is equal to what? Is equal to sine inverse NR over NI, which is Ni always bigger than Nr. Ni always bigger than Nr. This equation can be used only when Ni is greater than Nr. In other words, total internal reflection occurs only when the light moves along the path from the medium of the higher index to the medium with the lower index of refraction. If Ni were less than Nr, this equation would give theta critical greater than 1, which is an impossible result because the definition of the sine of an angle can never be greater than 1. Okay? Look at the sample problem 6C. Guys, look. The question says, find the critical angle. What is unknown? Theta critical is unknown. For water-air boundary. Water-air boundary. For the critical angle to be occurred, the light must be travels from high density to low density. So Ni in this question is equal to 1.333 for water. And Nr for air is equal to 1. What will be the angle of critical or critical angle? Critical angle is equal to sine inverse Nr over Ni. Critical angle sine inverse 1 over 133. Critical angle is equal to what? Is equal to 1 divided by 1.33 is equal to something. And shift sine inverse for the answer 48.6. 48.6 degree. This is the critical angle. If the angle of incidence is bigger than 48, it's going to be the total internal reflection. Okay? Question 1 in practice 6C. Glycerin is used to make a soap and other personal care products. Find the critical angle for the light traveling from glycerin into the air. From glycerin, high index to low index to the air. Okay? Calculate or find the critical angle. Question 1 in practice 6C. Theta critical is unknown. Ni for the glycerin is 1.473. Nr for air is equal to 1. Theta critical is equal to sine inverse Nr over Ni. Sine inverse Nr 1. Ni 1.473. Theta critical is equal to what? I got 35 degrees. This is critical angle of this question. Question 2. Calculate critical angle for the line traveling from glycerin to the water. Ni for glycerin is equal to 1,473. And R for water 1,333. Theta critical is equal to what? Theta critical sine inverse Nr over Ni. 1,333 over 1,473. Theta critical is equal to what? Divide by 1 point. For the answer 64. Okay. 1.33 divided by 1 point. Sine inverse for the answer 64 degree. Yeah. Okay. Question 3. Ice has a lower index of refraction than the water. Find the critical angle traveling from ice into the water. And I for ice 139. And R for the water is equal to traveling from ice. Find the critical angle for the light traveling from the ice has lower index of refraction than the water. Find the critical angle for the light traveling from ice into the air. And R is equal to 1. Theta critical is equal to what? Theta critical is equal to sine inverse Nr over Ni. Sine inverse Nr 139 over 1. Sorry. 1 over this number. 1,309. Theta critical is equal to what? 1 divided by sine inverse for the answer 49.8. This is question 3. And question 4, it's homework. You can solve by yourself. Okay. I prefer to solve this question by yourself. It's very easy. Okay. So that's all for today. Thank you for listening and keep up your best day.